Welcome to the teaching model question for C2.2. So this is around ionic bonding and how to explain how the properties link to the bonding in ionic compounds. So it's a six-mark question, so we need to make sure that we write in full sentences, but we'll worry about that later. For now, what we need to do is identify what we need to write. So magnesium chloride is a solid with high melting point. It conducts electricity only when molten or dissolved. Describe the electronic changes that take place in the formation of magnesium chloride and explain its properties. So I've got to describe the electronic changes, that's what it wants us to do, and explain the properties in terms of the bonding and structure. So the properties it wants us to explain are if you look back up here, it talks about having a high melting point and conducting electricity when molten or dissolved, so not as a solid. Apologies for my bad handwriting here. So in terms of the bonding and the structure, so we can use diagrams. So when it talks about diagrams, it's talking about the dot and cross diagrams for the electronic changes. So these need to be the dot and cross diagrams. So I'm going to start with a dot and cross diagram. So the electronic changes that take place in the formation of magnesium chloride. So whenever we answer these questions, unless it says to draw a full electronic structure, we just do the outer shell. So if we look in the periodic table, magnesium's in group 2. So because that's in group 2, it's going to be 2+ ion, and chlorine's in group 7. So it's going to be a -1 ion. And because we're Mg2+ and Cl-, we need 2 of the Cl-, so 2 of the chloride ions to match. So we need 2, if we've got 2+ as a positive, we need 2-. So the formula of that is going to be MgCl2. And remember, we have to be careful that because they're negative ions, these are called chloride ions. So anytime we talk about them, we need to say chloride ions. Quite a common mistake is for people to write chlorine ions. And that's not true, because it's only chlorine when it's the element. If it's turned into a negative ion, it's become a chloride. So we're going to do the electronic changes first, which is the most difficult. So magnesium's in group 2, so it's going to have 2 electrons in its outer shell. So remember, this is only the outer shell. And chlorine in its outer shell, because it's in group 7. Now remember, I draw dots for one and crosses for the other. So chlorine has got 1, 2, 3, 4, 5, 6, 7. Okay, so in terms of electron transfer, magnesium's got 2 electrons to lose, so it wants to get an outer shell. So so when we do this, let's write some notes for later. So the metal, so the Mg loses 2 electrons to become Mg2+, and the chlorine is going to gain 1 electron to become Cl-, and that is to get a full outer shell. So we can see this electron here goes into this gap here, and that still leaves another electron, so we need another chloride ion here. So 1, 2, 3, 4, 5, 6, 7. So that electron needs to go there, and that will then turn into, so Mg, and I'm going to draw an empty outer shell to show that that's lost its 2 electrons. And remember, because it's positively charged now, we need a square bracket. So my drawing here is leaving a bit to be desired. So we need a square bracket, and then we put the 2+ charge on the outside of the ion, because remember, the charge is not localized, it's across the whole thing. And then I've got my chloride ion, which has got 1, 2, 3, 4, 5, 6, 7. And then I need to put the cross because that 8th electron has come from magnesium. And then again, I need to put a square bracket around it, and that's minus. Now, because I'm doing this on a computer, I can cheat a little bit because we need to have 2 of those. In fact, I don't think I've drawn that quite. So, of course, if you're drawing this out on a piece of paper, you'll have to do it. You have to draw it out twice, or you can just write ×2. So that's my electronic changes. So that diagram shows the electronic changes, but we really should describe them as well. And then we need to talk about the bonding and structure. So we need to explain its properties. So if I just get back onto the pen here. Right, so our high melting point in ionic solids is because there's strong forces of attraction between the oppositely charged ions. And then the conducting electricity when molten or dissolved. So when it's molten or dissolved, that means, because it's a liquid or a solution, that the ions can move. And of course, the conduction of electricity is the movement of charged particles. When it's a solid, of course, in a solid, the particles only vibrate about a fixed position, so the ions cannot move. So they can't move past each other, so you don't get any movement of charge, so it doesn't conduct electricity. So what we need to do now is type this up into a coherent answer. So I've left myself enough space here. Let's just do a bit lower down, and then we can get a wider space. So let me just put my tablet down and let's type on this. So let's describe the electronic changes first. So as shown in the diagram, it's always a good idea to draw a diagram if it's suggested, because it's easier to explain things with a diagram, and it saves you having to write as much. So I think it's actually quicker to draw the diagram. So as shown in the diagram, the magnesium, so we need to be careful that we use atom and ion in the right places. So the magnesium atom loses 2 electrons to make a Mg2+ ion. Now, when you're doing this, you need to make sure that the 2+ is superscript, but it's difficult to do on this without faffing around too much. So the magnesium atom loses 2 electrons to make a Mg2+ ion. This has a full outer shell. Okay, so these 2 electrons transferred to 2 chlorine atoms, which become chloride ions. I'm just going to put it in brackets Cl-, and again that charge should be superscript, which also have a full outer shell. So we've described pretty much what happens in there. So the magnesium atom loses 2 electrons to become Mg2+, it's got a full outer shell, and then 2 electrons transferred. So we've done the electronic transfer diagram. Now we need to do the explaining properties. So let's describe the high melting point first. So magnesium chloride is an ionic compound. It has a high melting point is at a high melting point because there is a very strong force of attraction between the positive magnesium ion, sorry, another typo, my spelling isn't that bad, in positive magnesium ion and negative chloride ion. This takes a lot of energy to overcome, so the melting point is high. And then we need to talk about the conduction of electricity. So the conduction of electricity is the movement of charged particles, ions. So it's also in metals, it's going to be electrons, but we're not talking about electrons. And that's one of the common mistakes, actually, that people talk about electrons in here. And it's not the electrons that allow conduction in ionic compounds, it's the movement of ions. So in a molten or dissolved ionic compound like magnesium chloride, the ions are free to move, and so it will conduct electricity. In the solid, the ions cannot move past each other, and so the solid magnesium chloride does not conduct electricity. Okay, so let's just check I've answered everything. So describe the electronic changes, we've done that, and explain the properties, which is the melting point and the conduction of electricity. Okay, so let's click on that because we've now typos accepting got a perfect answer. So thank you for listening. See you next time.